Hi everyone, I'm Huseyin Yildirim from Duke University Economics Department. When I received an invitation from this conference, I was like, that must be a mistake. Well, how can I contribute to a finance group? I hardly see my finance colleagues at Duke. But then, this is, again, Savitar did an excellent job, but independent of that, I think this is an outstanding paper, and I don't make those comments very often. And let me elaborate on my impression, and also to recap, and then offer some comments either now, just or for the future. They're starting. The motivation is very clear. Investment decisions in firms are hardly made as a unified voice. They are made by committees, and as soon as you have committees, you need to talk about the approval rules, and then things get interesting, how information is aggregated and etc. And they actually did a survey of VCs themselves, which already impressed me. Unlike me, like, okay, let's rely on someone else's evidence, they actually surveyed the VCs and asked them, and as he explained very well, the champions rule for seed and early stages, and majority and more consensus rules for growth stage projects within and across venture capitalists, especially within a venture capitalist. So the voting rule by which they fund the project changes for the same within the same venture capitalist too. And as you can see, what is special about the seed and early stages is that these are the kind of projects like Amazon, Facebook. You are just catching a unicorn, basically. A lot of times they will fail, but if you hit the jackpot, then it will be really good. And those are exactly the cases where the VCs seem to use the champions rule. By the way, I like the positive terminology. We call it a dictatorship, which doesn't fly very well, but this is nice. I'm gonna use it myself. Okay, so then the objective is very clear. Explain the optimality of the champions rule. One advocate, one very enthusiastic member of the committee is enough, and explain it by heavy-tailed returns. And for broader audience, other than the investment decisions, like in economics, and also help select the appropriate voting model in the literature. And this is really important because economists are fascinated by the Condorcet type information aggregation models, which basically says majority rule is great. We should just aggregate information. Everybody should express their votes. But you never go down to dictatorship. That's like, one vote shouldn't drive it. And the underlying model is often like this. There is an unknown state of the world. Here it's the project value. And everybody gets conditionally independent signals. So it means that conditional on the project value, everybody basically gets a noisy signal, and because of that, this is a common value situation. Because of that, in these models, it's understandable that majority rule will be optimal because they will help filter the outliers, right? If 5 people have moderate signals and one has very high signal, it's more than likely that that very high one is driven by the noise, and it should be discounted. And more than that, if V is very high, the kind of project we are talking about, unicorns, then it wouldn't matter all that much, because the signals are going to be high for everyone. So we are going to say yes more than likely. So they turn then their attention to more recently studied models, what I call a model of expert committees. And this is probably the reason why I was asked to discuss the paper, because I have some recent papers. But this is a model actually, in general, it's known in the economics literature, in the auction literature, where people use interdependent valuations. And it's like the valuation is a sum of like the weighted average of the signals. These have been used by Eric Maskin and others early in the auction literature, but not in the committee framework until recently. So these are the models where the signal is not just conditional on the value. Our signals are just noise. Rather, the signal is actually affecting the fundamental. So here the idea is that the project has m dimensions, and we have n committee members. Each committee member is an expert on one dimension, one or more, but some dimension. But he or she also cares about others, of course. So that's the case. And now you can see that if I observe a very high signal as expert 1, it is not just a noise, it actually directly affects the fundamental. So then, then the rest is the same. Experts vote simultaneously yes and no, and project is accepted if K or more yes votes are generated. And the objective is to find the optimal K. Actually, if you look at it, this is a common value situation again, because expert 1, I know dimension 1, but I equally care about others. The general model is like allows for partisanship, which I will briefly comment. But actually, if you look at it, this is also a common value model, except that the signals directly affect the fundamentals. So, as Savitar said, the analysis is very similar to the other one, but I think it's more tractable as well. So what happens is that in a symmetric equilibrium, everyone again votes as if casting a decisive vote. And this is the indifference condition. So my vote is pivotal when K minus 1, others say yes. Then I condition on that. That's why it's truncated upward. And n minus K say yeah, no, and then it's truncated downward. So the symmetric equilibrium is unique because both of these truncated expectations are actually monotonic in the threshold. And it is decreasing. So as we go for the champions rule, like one yes vote is enough, then everyone else will actually increase their approval standard. So there is some compensation in the individual vote. And here the objective is, since this is a common value situation, just maximize the value of the project. So the main result is basically, as Savitar said, the champions rule is indeed optimal if the distribution, the prior distribution is sub-exponential, such as Pareto, with sufficiently heavy right tail. Oh, wow. Okay, so, and this follows from the catastrophe principle. One superstar attribute determines a superstar project's success. And so this fits nicely, really. So now, again, as I said, this is a very nice paper itself, outlier in my opinion, because they complete the circle. They survey, build a theory, and then come back and ask these individuals if their theory is actually holding water. That's the part I really like it's a full circle. But still, it can be improved. So my first comment is about the dynamics of the voting rules. The paper suggests that there is some repeated funding for funding decisions for some same projects, then I wonder, suppose the committee votes on the same project or plans to vote on it in 2 periods, seed and growth. But then they make one claim. I thought initially, I mean, it's obvious, but is it clear that conditional on the first period return, the second period return is light-tailed? Therefore, in the second, in the growth stage, we turn to majority rule. I thought this was, yeah, I mean, it should be since we learn more. But then I looked at Pareto. Pareto conditional on X, like conditional on the return being greater than something, is again Pareto, and I verified it actually. I looked it up on Wikipedia and I said, this can't be right. I mean, there must be something. And then, so that is still actually heavy-tailed. You know, that needs to be formalized. And suppose it is, suppose I'm wrong, then would dynamics favor the champions rule in the first period even more? I think so, because in the second period, we are truncated now. We are like rejecting the projects. We are only accepting if they do well. Therefore, the investment cost will actually look smaller in the first period, and that should favor the champions rule in the first period. My second comment, Savitar actually answered it at the last minute. So the model is using this additive specification and then comes to the maximum equivalence only at the tail, which is exactly what they want to explain. And then they have this, they say that, well, if we had like minimum, like a technology where the project value is like O-ring, like we care about the weakest link, then of course unanimity would do the best. Then I can say, well, the counterpart of that, if V is maximum, then regardless of F, probably the champions rule would be optimal. But you don't want to diverge from the role of the distribution. Therefore, when you said if the tail is on the negative side in the additive model, then K equals N. I mean, that would be, if that's optimal. So, yeah, what I'm saying is that stay with the additive model, at least in this paper, because you want to use the power distribution as one of your explanations. And that appears there. And the other thing I want to say, this is like more a general comment. They explain, well, like the heterogeneous preference, a lot of nice extensions. But in general, in this literature, these committee members, the partisanship, the bias is also modeled as, I care about my signal. I'm an expert on dimension 1. I know what I know. I care about others, but not as much. That's kind of the heterogeneous preference aspect, and that may also lead to K greater than 1. So, yeah. Overall, I want to end with their, I think it's the last sentence in the conclusion. And I fully agree. It got me thinking about hiring decisions. We are trying to catch unicorns in the job market. Then why are we using majority rules in voting? Like, why not go with like one person? I want to hire this person, and then let's agree on that. I don't know. That may well be the explanation that people the heterogeneous thing, that the over championing idea may explain it, and also we can't fire people. Here projects can be not funded. So, okay, yeah, thank you very much.